So we've been digging into the idea of sampling and sampling theory in the context of experimental research designs. I'd like to flesh out that a little bit over the next two conversations as we talk about sampling and how to do it well and some of the limitations. So let's begin with just sort of big picture. One of the things that social scientists are aware of is that our own individual personal lived experiences, while valid for us, aren't necessarily a good foundation on which to generalize to the larger world, right? Our individual experiences are sort of rooted in a certain place and time and location and network, and we don't necessarily have a good sense of how generalizable that is to the larger world. We're going to use that word generalizable a lot. My ability to sort of say something about the larger world based on a limited set of data. And so we, as social scientists, oftentimes try to move beyond our own personal experiences by collecting more information about the larger world. But we run into a second problem, which is that we can't possibly study everything. And so we're oftentimes forced to look at a subset of information or cases, and how we select those cases ends up being really important. Because if we select cases in a way that isn't representative, and that's another word that we're going to be using a lot, representative in the sense of looks like or resembles or is comparable to the patterns that are going on in the larger world, we're sort of back in that same problem of I'm looking at something that doesn't really tell me about the larger world and trying to draw generalizable conclusions from that. And so a question that social scientists are oftentimes wrestling with is, I've selected this group of cases to study and situations to look at. How representative are those cases? And can I tell a larger story based on that? Now, as we talk about that's essentially the problem of sampling. I want to quickly hash through some vocab. So we'll start with population. Population has sort of a colloquial meaning of everyone. So 7 point something billion people on Earth, or 330 million people in the United States. In the social sciences, that's not what we typically mean when we're talking about population. In sampling theory, population is the group of people or cases that we are interested in understanding, right? What are we trying to study? That's our population. I tend to use the word target population, or the phrase target population, to try to differentiate the colloquial meaning from the sort of social science meaning, right? What are we trying to understand, generalize to? What is it that we're trying to study that we can't necessarily get at with our own limited experiences? So we have a population, we have a census. A census is a study of the entire population. If your population is relatively small, say the number of people who are taking this class, I can certainly sit down and chat with every single person taking this class. There's like 40 of them, not a problem. But if your population is, or your target population is a larger pool of people, right? So everybody in the United States or eligible voters, you're probably not going to be able to do a census. You're probably going to bump up against time limitations and resource limitations unless you are a government and can marshal those sorts of resources. And so every 10 years or so, the United States government conducts a census and tries to reach out and connect with every single person in the United States. Is that a good way to go about conducting social science research? Probably not. It's very labor intensive. In fact, the Census Bureau has argued that the challenge of trying to reach every single person actually produces results that are kind of wonky, and that they're aware that they're missing people and just having a hard time reaching certain people. And so the Census Bureau has actually argued that they can get better results through sampling, which is looking at a subset of the population and studying that subset and doing that in a rigorous, systematic way. Now, you might ask, well, if they can get better data through sampling, why do they conduct the census? And it's because the Supreme Court has looked at that and said, no, the census is in the Constitution. And it's not just simply about getting an accurate population reading for purposes of allocating districts. The purpose of the census is that every 10 years, every person has a right to expect that their government will try to reach out and connect with them, to acknowledge them, that your right to be counted comes with membership in this political community. So the Census Bureau sort of looked at it and said, okay, fine, we'll do our census. Can we also do sampling? And sure enough, the Census Bureau conducts regular samples of the United States to get additional information that we can use. But anybody can conduct a sample. Samples are much more within sort of the zone of reasonable ability. We're looking at a small subset drawn from the population and using that. I'll talk about sampling frame really brief. Well, maybe not really briefly. I used to sort of gloss over sampling frames because I assumed that it was a negligible issue, but the more I've sort of looked at research designs, the more I've realized that no, this is actually an important thing to pay attention to. The sampling frame is the set of cases or individuals from which we draw the sample. Now, in an ideal world, our sampling frame will resemble our population or will be identical to our population. And that will help us to say when we draw our sample, this sample reflects the population. But a sampling frame doesn't necessarily have to map the population perfectly. It might just be sort of close enough. And so I could give an example. Oftentimes people draw samples using telephone numbers, random digit dialing, and calling up people who have phone numbers attached to them. And that works really well, except there are people out there who don't have phone numbers attached to them, who you can't reach through a phone, and they're not going to be included in your sampling frame. That your method of drawing that sample, the pool of people from which you're drawing, but they might be part of your target population. And so oftentimes those different, well, no, I shouldn't say oftentimes, hopefully those differences are small, right? And we can say, well, it's a handful of people and it's probably not going to radically change my results, but we should always be checking that. We should always be asking that question, is there a gap between the target population that I want to know something about and the sampling frame from which I'm actually drawing my pool of cases? Lastly, I should talk about sampling unit. This is a vocab term I don't particularly care for because there's not really consensus on it. Some people use the term element or case. It's basically when you draw your sample, each person, each case that you're selecting, that's a sampling unit. And so if you draw a sample of 1,000, you have 1,000 separate cases or sampling units that you might look at. Okay, so we have some language about samples. We understand that sampling is likely part of what we have to do in social sciences. We have some ideas about what to do to make it better, and we certainly know what makes sampling bad. The worst sampling method that we could possibly use is just an ad hoc sampling method of these are people I know and I can get this data really easily, and so I'm just going to do that. That oftentimes replicates the same problems that we have in our own personal experiences of we get this like limited snapshot of the world that's not necessarily representative. If I reach out to my friends on Facebook or people who follow me on Twitter, I'm likely not getting a representative sample from that group of people, but it is easy, right? I can just type in some characters and hit send, and suddenly I've got a call or a poll up that I can get data back. Asking people that we know or allowing people to sort of give voluntary response to out of convenience is oftentimes not going to give us the kind of results that we want. And I'll just sort of leave it at that we can do better. That if we're thoughtful and purposeful, we can get better results than just simply grabbing what's convenient and easily around. Okay, so what we should be trying to do is we should be trying to get a random sample of the population. Random sampling is considered the gold standard for most social science research, and if you can do it, you are going to get better results if you do that. What we mean by random sampling is that each person in the target population or each case in the target population has an equal probability of being selected. So nobody's being sort of given a better chance of being studied than someone else. And also we can't necessarily anticipate ahead of time who's going to be drawn as part of that sampling process. And that's important because it can help reduce the researcher bias or researcher induced bias, where we might be making subtle decisions that affect what we actually get in our results in a way that makes them not representative. So randomness helps to reduce researcher-induced bias, but randomness also is nice because statisticians have studied randomness and how random samples behave, and we can say some things fairly precisely about how random samples relate to the larger population. So it helps us with that generalization piece that we want to be able to do. Now, I should flag quickly that simply because we've set a process up to look random doesn't necessarily mean that we've actually got a random sample. So I oftentimes use the example of if I was trying to study people who are traveling across state lines, right? North Dakota to Minnesota, that sort of a thing. And I decided that I was going to do a random process. And so I selected randomly Amtrak stations around the country. And I sent people to those Amtrak stations and I gave them random instructions, which are, you will interview every 50th person who walks through the door, right? That process might look random on the surface, right? There's the random element of selection of train stations, and there's the element of I couldn't possibly know who's the 50th person who's going to walk through the door. But I've made some decisions in how I've selected that in terms of what my sampling frame looks like, where I'm not actually capturing the entire pool of my target population of people who are traveling across interstate lines. I'm not getting people who are driving across interstate lines or people who are flying. And those people may differ from folks who are taking Amtrak in significant ways, right? Folks who are driving probably have a car. Folks who are flying maybe are flying business class, or are in more of a hurry, or have more money to get their long distance travel done quickly. Right. And so if I choose to do this random process, but my sampling frame doesn't necessarily line up with my target population, I can still get biased results. I also have to deal with the human element, right? So I could, send people to airports as well, and I could send people to interstate rest areas as well. And I've got a better sampling frame that looks closer to my target population, but I'm looking at the results and I keep getting more women than men in my results. And maybe that's a function of more women than men are traveling interstate. But when I dig into it a little bit more, what I find is that one of my survey people has a side hustle, and she sells makeup through Mary Kay, and she's using the survey process to basically chat up women who she thinks could be clients and then passing them their card, right? So there's this human element where people could be making subtle decisions for reasons I don't anticipate that end up biasing my sample in ways that make it less representative. So just simply having randomness in our process isn't sufficient. We need to be thoughtful and systematic about that. So if we're trying to be thoughtful and systematic, one way to do that would be to use a sampling interval process. And to do this, we need a list of all the people in our target population. And if we have that, then we can sort of put them in a random order, or we can take the order that we have and select a random point on that list and start counting. So if I've got 1,000 people and I want to sample 100, I need every 10th person. So I would count sort of 1 through 10, and then check that person, say, okay, you've been sampled. And that's a process in which every person has the same probability of being selected, because everybody could, in theory, be that 10th person on the list. And it's a process where I could never anticipate ahead of time who would be included, because I've started from a random point on the list. You can do something similar with Excel with using the random number generator and sorting things in order. That's another way to sort of take a list and draw a random pool, a random set of cases from that. But it does require that we have that list. And if we don't have that list, it gets trickier. Probably the most widely used workaround to get a sample that looks random, where everybody more or less has the same probability of being selected, is to use random digit dialing, where you get computers to generate random numbers that look like phone numbers. You dial those phone numbers, and you have no way of knowing who's going to be on the other end. You can never anticipate that ahead of time. And because a good chunk of the population is carting around a portable phone with them most hours of the day, you're likely to get the vast majority of the population included in that. Random digit dialing also has something that statisticians kind of like. It's sampling with replacement. What that means, well, I should say, the interval method, once you've been selected, you kind of get pulled out of the pool. You're no longer part of that pool. But with the random digit dialing method, it's possible that a computer could randomly generate your phone number twice, and you could be called twice for the same survey. So you're simply being selected doesn't pull you out of the pool. You get placed back in the pool and could be drawn again. Statisticians like that. I think it makes the math easier or nicer, but for practical purposes, I don't know that that's a distinction that's worth spending too much more time on. But there are lots of situations where it's not necessarily going to be possible to get a random sample, because the target population that we have is not amenable to simply calling up random phone numbers, or we don't have a master list because the population is kind of amorphous, like people who are traveling across state lines. I don't know what that population necessarily looks like, or how to get at it, other than to simply try to catch people in the act of traveling across state lines. So there are a variety of other strategies that people use. And so I'll talk about stratified sampling, which tries to preserve an element of randomness, quota sampling, which sort of throws out the randomness and says that's not really what we're trying to do here, and snowball sampling, which is used when we're trying to get at very obscure populations that happen to have social networks connecting them. So with stratified sampling, we are trying to create a randomish process to drill down to specific individuals that we can study. And we're using the fact that there's maybe sort of geographic organizations around people that we can use. And so if I'm interested in studying guidance counselors, I might intuit that guidance counselors tend to be attached to school districts, and school districts tend to be attached to cities, and cities are attached to counties, and counties are attached to states. And so I can draw a random selection of states. Maybe I'm interested in, half the states, and so I flip a coin for each state on the list, and if it lands heads, that state remains in my list of states that I'm going to sample. If I could then go through and identify all the counties in those remaining states, and I could use a random process to say I'm going to sample 5% of the counties or 10% of the counties. Roll a dice, 10-sided dice, and if it lands fives, we're going to keep them. So then I've sort of found a random subset of counties. Now I can go and look up all of the cities in those counties and select a random pool from that. And I can look up all the school districts there, and I'll go to the school district web pages and take every third guidance counselor. And so that's a process in which there's randomness injected into the selection. I could never anticipate ahead of time who I would possibly end up on my list, but it's not a random sample in the way that the simple random sample of just taking every 10th person off a list is, because there are things that are going on where maybe I don't really understand that selection process. So one thing that kind of jumps out to folks when I give the story about school districts is that there's a lot of rural school districts, and urban school districts seem to be really populous with lots of guidance counselors. And so if I'm doing this method of selecting through counties, aren't I going to get a heck of a lot more rural school districts? And the answer is, yeah, probably. That's probably going to happen. I might have to figure out a way to adjust for that. Maybe I'm weighting based on population. So every 1,000 people in a county, I list that county in my database once for every 1,000 people. So I'm essentially waiting for population. So counties with 1 million people get to be listed 1,000 times and thus have a greater probability of being selected. I'd have to adjust for that. But the problem with a stratified sampling method is that I might not always anticipate all the ways in which my process that I've set up and tried to make random is actually steering me toward a unrepresented shared population. And yet there's not necessarily an easy workaround for that or an easy fix. And so people have long used stratified sampling in places where there's not widespread telephone coverage, and have gotten very elaborate in creating sort of protocols to get at sort of a random person. It might be, start at this randomly selected intersection, walk 5 minutes north-ish, at the next left-hand turn, take that and walk 3 minutes west-ish. When the timer goes off, you're going to stop and you're going to find the first house on a corner, right? That kind of set of instructions could create a process where somebody finds themselves at a door that they could never have anticipated ahead of time. And you can pair that with different random processes to get something that looks random, but might not necessarily behave the way regular samples do. Okay, we could throw out the whole idea of randomness altogether and say, I'm not going to be able to get a random sample the way that I would maybe want. And so I have to take it upon myself to ensure that my sample looks like the larger population. I can't trust that to randomness, that's going to happen. And so I'm going to set up targets, quotas maybe, that I want to hit. And so maybe I want to make sure that my sample is balanced in terms of gender, men and women. Maybe I want to make sure that my sample has the same age distribution as the population. Maybe I want to make sure that my sample is balanced in terms of race, reflecting the population. And so I find myself in a situation where I need to find 50 white men between the ages of 18 and 25, and 50 white women between the ages of 18 and 25. And my job in sampling is to find people who fit those categories, sample them, survey them, study them, and then sort of check that box and say, okay, I've got enough people in this category. Now I need to find African-American men between the ages of 18 and 25, and African-American women between the ages of 18 and 25. And maybe I need a smaller number because proportionally, they're a smaller portion in the larger population. So quota sampling is a way that you can produce a pool of people, a sample that looks like the larger population in what we think are theoretically important ways. But we don't necessarily know if our selection process of how we filled those quotas is giving us a biased result, or if it's giving us a representative result. But what we can say is that we're matching the population on certain dimensions. A third strategy, snowball sampling, uses social networks and is useful when we're trying to find populations that maybe aren't easily identifiable. So if I was interested in studying intravenous drug users, right, I might be able to use social networks to track through that and find folks who are, using heroin. The example I often use, because it has sort of a follow-up example, is if I was interested in studying vegetarians. If I was interested in studying vegetarians, maybe I would sort of intuit that vegetarians participate in vegetarian social media sites or know other vegetarians that they go out to dinner with, or have run into other vegetarians in cookbook aisles, struck up conversations about Mark Bittman or something like that. And I could use those social networks to try and find a pool of the population that would be really hard to get through just sort of calling people up at random and saying, hey, are you vegetarian? And if so, would you complete my survey or participate in my study? And so with snowball sampling, what you do is you find one person in that group and ask them to give you referrals to other people in that group. So you use their social network and sort of build out. So you go to that next group of people and say, hey, I'm doing this study, would you participate? And by the way, would you give me 3 or 4 names of people that I can talk to? And through this, you get sort of this snowball effect where things sort of spread out. Now, it's not going to be random. It's not going to be random at all. But it is an improvement over your own sort of individual personal social network for drawing inferences, because you're building out through many people's social networks, but it's not perfect and is vulnerable to some real big problems. So one of those is that you don't know what that selection process looks like. With vegetarianism, so that is a broad umbrella term that covers a lot of stuff, including vegans. And so if you're first person that you're interviewing is vegan, and you ask them for referrals to other people who are vegetarian, they may sort of mentally check off and say, well, what you really mean are vegans, because they're the folks who are like really serious. And well, I know Joe over here who is vegetarian, but sometimes has fish. I'm not going to give you Joe's name, because I've made a decision that Joe doesn't belong in that study. And so people can bring their own biases in terms of how they pass that network along to you. And you can find yourself trapped in sort of the vegan network when you thought you were sampling vegetarians. Okay, there are ways to get around that, or ways to make that better. One of those is to not start just one snowball rolling and collect people through that process, but instead to have multiple snowballs rolling. So, maybe I did accidentally choose the person who's vegan and starts me on the vegan path. That's fine. I need folks who are vegan in my study of vegetarians, but I also need folks who occasionally have, fish, because they're part of that vegetarian sort of broad umbrella too. And so I want that snowball rolling as well. And so hopefully I'm getting multiple different social networks. The other thing that I can do is I can ask people, don't give me your best friend. Don't give me the person that you know really well and like sees the world exactly as you do. Reach to the edge of your social network. Reach that person that you ran into at the bookstore in the cookbook aisle and you had a conversation with and you happen to remember their name because you bumped into them somewhere else, right? That's the person I want. The person who is sort of a random encounter that you can pass along to me. And so between those two strategies of having multiple snowballs rolling and pushing people to get to the edges of their social network rather than the inner core of their social network, we have a better chance of getting not necessarily a random sample, but maybe a more, I'm not even sure I want to say representative sample. We've taken steps to counter some of the biases that can come with the selection process that we've started. And we can say confidently that while our results might not be fully representative, they're at least a useful snapshot. And that's sort of the line that we oftentimes walk between random versus non-random sampling. That with random sampling, we can say some things about the larger population because of how randomness works. And we'll talk about that. With non-random sampling, what we can say is that I think this is better than just using my own anecdotal experience. I've taken some steps to be systematic in my collection and to try to avoid obvious pitfalls, but I don't necessarily know how my sample relates to the larger population. I can look to try to check to see if it's representative. I can sort of think creatively to see, did I make decisions that obviously biased my results? And I can try to minimize those. But we don't always have a good way to link our non-random samples to the larger population, other than sort of that conversation. Is this a reasonably defensible way of selecting your sample?